Good evening, ladies and gentlemen, and welcome back to another installment of Math with Kieno. This is a special viewer request video. If you ask questions, if you have doubts about something or weaknesses, you can just shoot me a message in the comment box and I will respond. Two viewers actually sent me some requests, and I would like to mention your name, but you haven't really said whether it was okay to mention your name, so it's kind of like a gray area. Like, I don't want to be like, oh, well, blah, 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 requested this video. So in the future, all of you guys, if you want me to, I guess, mention your name or say it's okay to mention your name, otherwise I won't assume that it's okay. So, I'm sorry, taking a swig of hot tea. It's getting cold in this region. The viewer requests were one person was having issues with fractions and word problems, and the other one was having problems with, what was it? It was probability and distance, rate, and time problems. All right, so probability I'm not going to do today. I'm going to address the fractions, and I am going to address the distance, rate, time problems today, and I'll do a later video on probability. So enough of me yapping. Let's get into it. Okay. So, let's jump into the first one. Okay. Now, the viewer was having problems with word problems and fractions, so we're going to do adding, subtracting. They're having problems with how to position it. So, Sandra bought. She bought, what'd she buy? 2 3/4 yards of red fabric. She also bought what'd she buy, guys? 1 1/4 of blue fabric. All right. And the question will ask, how much fabric did she buy in all? And I'll just say it. There's no reason for me to So we want to know, how much fabric did she buy in all? Okay, I'll go ahead. How much fabric did she buy? Question mark. Okay, so how much fabric did she buy? Okay, we're going to pull out the 2 3/4, and we're going to pull out the 1 1/2. Okay, we're going to forget about everything else. We're working these word problems. All right, so this is going to be an addition setup. Okay, so we're going to add 2 3/4, 1 1/2, and then we're going to come up with our number. So we can get rid of that. The magic of dry erase words. All right, so these are the two numbers we're going to work with, and we're going to add. So we zero in on those numbers in the whole set, and knock out the bottom lines. Okay, 1 1/2, and it's going to be an addition problem. All right, now here's my thing. Isolate the 2 and the 1. Don't worry about that. Let's focus on the fraction part, not the whole number part. So we have 3/4 and 1/2 that we're going to be adding together. Okay. So, I need common denominators. Okay. Now, I can do this one of two ways because it's addition. All right. I could do the old-fashioned way and be like, okay, 3/4, and this needs to turn to 4, so we need to multiply the denominator by 2 to give us 4, and then the numerator by 2 to give us 2. And then we have 5/4, which is basically 1 and 1/4. But this 1 has to go to the whole number side, so this would actually be 4 1/4. Okay? Or I like my rapid math version. You know, I try not to if I don't have to go through all that. But 4 1/4 is what we got before, dealing with the fraction part of the problem. I cross multiply numerators and denominators. So this is 6, 2 times 3 is 6, plus 4 plus times 1 is 4/8. Okay, so I'm going to get 10/8. Okay, I'm going to reduce 5/4. And this is still 1 and 1/4. I kind of like my method. I won't call it my method. It's the method that I use. So that's our answer. That's how much fabric she bought in total if you add the red fabric and the blue fabric. So again, take your time. Watch this video again. And again, if you need to. Okay, for our next question, this will be another addition of fractions. I guess I'm spoiling, that's a spoiler alert. An equilateral triangle, this is a symbol for triangle, an equilateral triangle measures 3 1/2 inches on one side. What is the perimeter of the triangle? Okay, you can pause there, you can think about it, you can try to work it out on your own at this point. Alright, so we have an equilateral triangle, and I am going to try my best to draw. It's pretty decent. What do you guys think? An equilateral triangle is a triangle where all 3 sides are equal. Some other information, if you don't know about an equilateral triangle, it has 3 angles inside. Those angles measure 60 degrees when it's equilateral. Has to be. If all the sides are equal, 60 degrees, 60 degrees, 60 degrees are the angles that are on the inside. But we're not asking for that. That's just some extra information I threw in, just for your own edification. Now, they say one side is equal, and we'll put S. It's equal to 3 1/2, or we could call it 3.5. Alright. Put the or there. So we call it 3 1/2 to 3.5. Now, what they want to know is, what's the perimeter? Well, we'll call each side S, and we know that S is 3.5. So perimeter is basically, if we took a walk around this side, and this side, how far will we march? Okay, and another thing we could do is we could label angle A, angle B, angle C points. We could call these points. Alright, so if I walk from A to B, B to C, and C back to A, how far would I walk? Alright, and we're not going to label these with units. These units can be miles, feet, yards, meters, kilometers, whatever. The number is the important thing. So the perimeter would equal S plus S plus S. So if we plug in the numbers, 3.5, or no, this is a fraction video. Let's keep it 3 1/2 plus 3 1/2 plus 3 1/2. Alright, so essentially this is the perimeter. Now, you could work out this thing, you could finish it off algebraically, but I would prefer just keeping stuff simple. If we have 3 plus 3 plus 3, that's 9, and if we have a half and a half, that makes a whole, 10, a third half, 10 1/2. Okay? Plain and simple. I mean, we could have went through math, but when you have wholes and halves, it's pretty easy, and there's no use of make yourself work harder. Okay, so that was another addition word problem concerning fractions. Okay, in this question, Alan had 6 books. He read 1/3 of the books. How many books did he read? This is a multiplication problem. Let's see, we're going to focus on the 6, and we're going to focus on the 1/3. Alan had 6 books. He read 1/3 of the books. How many books did he read? Okay, we're going to take our 6, and we are going to take the 1/3. And all we need to do with this is just multiply it to find our answer. Okay, so we'll multiply, and always look at this as 6 over 1. Every whole number is a fraction, in essence. And every fraction is a division problem. Let's see here. If we took, checking my real estate, 6 over 1 is 6 over 1 because every fraction, like I said, is a division problem. Equals 6 because 1 times 6 equals 6. That's how you have to look at it. Start at the numerator, counterclockwise rotation. 1 times 6 equals 6. That's how you have to look at the fraction, or that's a way you could look at the fraction. So multiplying fractions, 6 times 1 and 1 times 3 will give us 6 over 3. Again, our counterclockwise rotation method. 3 times what equals 6? Well, you could say 6 divided by 3 is equal to 2. No remainder. So 2 books have been read. Okay? And if you don't get it, just take your time, look at it, pause it as much as you need, and just follow it. We'll do another one. Okay, and our next question. Eric had 4 apples. He ate 1/2 of the apples for lunch. How many apples did he eat? All right, now in this case, you could do this 2 ways. You could just look at this simple and be like, okay, all right, he had 4, he ate half. So we know that 4 is our total. And if he ate half, then that's 2. And 2 apples is what he ate, Eric ate for lunch. All right, if we want to set this up in a fraction form, basically, like I said, if we take the total number 4, 4 is equal to 4 over 1. Okay, we can look at it as a fraction or a whole number. It's your preference. But if we take 4 apples and we multiply by 1/2, then that is going to give us or yield a result, which 4 times 1 is 4, 1 times 2 is 2, and just by division, we come up with 2. So you got to look at every fraction like its own little division problem. All right, so we answered the question. Thank you. All right, and for this question, a baby's t-shirt requires 4/5 of a yard of fabric. And then we have 48 yards of fabric. And we just want to know how many baby shirts can we make. Now, this is a division problem, but every division problem in fractions turns into a multiplication problem. So we're going to focus on 4/5 of a yard and our 48 yards. All right, and the question is going to look like 48 times 4 over, I'm sorry, not times. Jumping the gun there. Sorry about that, folks. 48 divided. So we're going to say, we're going to look at this and be like, all right, this is how much we have, and this is the fraction of what's required to make one shirt. So 48 is going to be divided by 4/5. And in order to work this problem out, we're going to have to flip, we're going to have to multiply by the reciprocal of 4/5, which is 5/4. Okay, so at this point, like I said, every whole number is expected to be a fraction. 48 times 5 and 1 times 4. All right, so I could see the 48 times 5 is 240 over 4. So we can make 60 baby shirts. Okay. All right, so that is how we work that out. If you have any comments, questions, or requests, any additional requests, just let me know. But we're going to go into the distance, rate, and time problem. We're going to do a couple of them, sorry. Okay, and our next question, distance, rate, and time problem. A family travels from Rochester, New York to Washington, D.C. It's 520 miles. The average speed limit is 65 miles an hour. How long will it take them to get there? Okay, this is pretty easy. All we need to do is total miles. And remember the formula, always. Distance equals rate times time. All right, so our distance is 520 miles, 520. And our rate is going to be 65 miles per hour. So in order to get time, we just divide 520 by 65. All right, you can do that with your calculator, but you're basically going to come up with 8 hours. If you work that out with your calculator, you just plug in 520 division key 65 and then hit equals, and you will come up with 8 hours. All right, more to come on distance, rate, and time. Stay tuned. Okay, in this case we have a different problem. We have 2 jets. Okay, the 2 jets leave Chicago at 8 a.m. The speed of the first jet is 10 less than 2 times the speed of the second jet. In 3 hours, they are 1,050 miles apart. Find the speed of each jet. Again, we're going to have to set up a table. We're going to have to pull the information out. Okay, so we're finding the speed of each jet. We're going to have to find jet 1. We're going to have to find jet 1 and jet number 2. All right, and then we are going to set up rate, time, and distance. And essentially it's just saying distance equals rate times time. It's just flipped around a little bit. So 8 a.m. means absolutely nothing. It's like irrelevant. You don't even really need to bother with that. All right. We want to find the speed of the jet. So jet 1 All right, the first jet is 10 less. All right, so we'll assign jet 2x because this is where the variables get weird. Okay, the speed of the first jet here is 10 less. That tells me we're going to be minus 10. Then 2 times, 10 less than 2 times 2, the speed of the second jet. All right, so it's going to be 10 less than 2 times the speed of the second jet. So don't worry about it. Don't panic. Just think. We're going to have an x. We're going to have a minus 10 because it's 10 less than 2 times. So we put a 2 there. So 2 times 2x minus 10 indicates 10 less than 2 times the speed of the second jet. All right, and this is the speed of the second jet. We don't know what that is. That's x. All right, so we have the rate information filled out. Time in 3 hours. In 3 hours, they are 1,050 miles apart. So it's not bad. Our distance in both of these are going to equal 3 times, or no, I should put it in parentheses. Same thing, but I need a container. I need to contain this. 2x minus 10 and 3x. This plus this equals 1050. So we take the 2 jets and combine their distances and their rates and times, and then that equates to the distance. And I'll show you up here. 1050, and it will be, you can say 3x plus 3 times the sum of 2x minus 10 equals 1050. So if we, as we come down, it will be 3x plus 3 times 2 is 6x. 3 minus negative 30 equals 1050. All right, 3x plus 6x is 9x. And that leaves us with 30 equals 1050. Now, you can think of this as adding 30 to both sides to get rid of the 30. But I just think of it as 30 going to the other side of the opposite sign and changing signs. However you want to mentally work that out is fine. So, but this cancels out with this, and 9x is equal to 1080. And to find the speed of the second jet, we divide each side by 9. And let's see, do I have real estate over here? Yeah, I got a little bit. 1080, 9, 1, 9, 1, 8, 2. So the speed of the second jet is 120 miles per hour. All right, so this guy's 120. If he's 120, then jet 1 is 2 times 120 minus 10. So 2 times 120 is 240. 240 minus 10, 230. So jet 2 is 230 miles per hour. So we found the speed of each jet. Jet A is 120. Jet 2 is 120. Jet 1 is 2 times 120 minus 10, which is 230 miles per hour. So that's our last distance, rate, time problem that we're going to do. I really hope this helped. Just add comments in the comment section if you guys need any more help. Thank you for watching Math with Kieno. Have a good afternoon. Bye.